Hi, and welcome to my weekly wrap-up. This is number 10. I am a Master of Forestry student in my second semester at Northern Arizona University. I'm reporting on 3 of my classes: Forest Insects, Ecological Economics, and Independent Study. Before I move forward, though, I want to go backwards to my experiment from a few weeks ago, and I never got any bugs to come out. All right, so this week we're getting to talk about how plants fight back against all these cool insects we've learned about. They do that in 3 ways: structural, chemical, or behavioral. And those can be indirect or direct ways, and they can be constitutive or induced. One thing to remember as we go over it, though, is that any kind of defense that the plant has comes at a cost, because it means it is not spending that energy to either grow or towards reproduction. Right, for structural, one way it can do it can just regrow the lost plant parts, and that works really well for fast-growing plants. Another way it can do defenses is by creating thorns, or with trichomes, which are hairs. The plant can make its parts just less palatable, so it doesn't taste as good. One way it can do that is with salicylic acid, and that is something you could find in a willow. It also makes, just like the lignified cell walls are often not easy to penetrate, the lignin is the part of the cell that gives it the rigidity and helps the tree have that structure, or any plant that has structure. Let's see, they also can just create sap, and that's really sticky, so that can be a physical barrier for insects to not be able to penetrate into the goods. One thing that they do is trees can hide. I bet you did not know that trees play hide and seek. But one thing that they do is they just make themselves less abundant in the landscape. That's obviously not what my ponderosa pine forest is doing here, but that does work well in tropical areas where they just are scattered, so that it is harder for insects to jump from the same type of plant to the next plant. And another way that they hide is they just don't release as many compounds, so that way it makes it harder for the insect to find it also. That leads us to the chemical types of things that plants do. Most of those are qualitative, because the plant makes decisions. It decides on what type of volatile it is going to release based on what type of insect is coming after it. So they are called green leaf volatiles, GLVs, and the plant will decide what kind of insect is attacking it, and then it will either release those into its leaves, so that the leaf now has a compound in it that the insect may not find as desirable, or that can also happen systemically, and all of the leaves in the plant can be affected by that. And it also takes volatiles and releases them into the air, and it will be a calling card for the natural predators of that insect to come to the aid of the tree, and that will also potentially affect its neighboring trees. A classic example is with the giraffes in Africa and the acacia trees. When a giraffe is eating one acacia tree, it will try and make the rest of its leaves bitter, and it sends out the volatiles, and the acacia trees downwind will also start putting those volatiles, their own volatiles, out into the leaves, so that the giraffe will come to the tree and say, "That didn't taste good," and it will keep moving on. Okay. Oh, and also another thing that the plants do is they take those different types of chemicals that they create, and they will apply them to specific tissues. So, for example, an apple tree puts cyanide in its seeds so that the insects don't want to eat it. And then they could also put those same chemicals in the new leaves, so that's a very important, precious part to the plant, and that will create the dislike for an insect to eat those new leaves. Another type of a chemical is a photooxidants. Those are very poisonous. They can affect the molting and development of the insects. They can even affect the DNA of the cells. And you can find photooxidants in wild parsnip. It will give you a rash as a human, but it's very, very poisonous if you're an insect. Okay, pyrethrins is another type of chemical process that a plant has, and those are in the daisy-like chrysanthemums. Those have been used for 2,000 years as a method for insect control. You can buy the pyrethrin powder in a garden store. One nice thing about it as an insect control is that it does readily decay into the environment, so it doesn't leave that kind of negative trace that other insecticides might. But they also said that it readily disappears in sunlight, so I don't know, maybe you're supposed to use it at the nighttime, but just be aware of that. Another thing that some plants do is they are capable of, if they live like in volcanic areas that have, the soil has a lot of metals in it, they can take those metals and they can sort them out into just the cells of their wall. That is most likely a response to being able to survive in that type of soil, but it works as a defense against insects. So the plants take like nickel or zinc or cadmium or cadmium or lead, and they can pull it up out of the soil. So as humans, we take advantage of that and use bioremediation to put those types of plants in an area that the soil is really bad. This plant pulls it up into its cells, and then we remove the plant, and that is one way that we are able to clean up polluted soils. Terpenoids is another chemical that the plants use. Those have a strong smell, like lemons or the evergreens of the trees. If you were out here today, it would be a lovely smell that you could join me with. The terpenoids work really well against generalists to keep the insects from coming after the plant. However, specialists have often figured out a way to take those terpenoids and use them to their advantage. Like for the bark beetle, it will take the terpenoids and turn it into a pheromone, and it sends it out to other bark beetles, kind of like announcing, hey, we made it through the barrier, party's over here, and then all the bark beetles will show up because they know that they can get in and start eating that tree. Let's see, that brings us to behavioral. And so, like I said, the trees can do volatiles to attract the natural enemies. And the thing that's interesting is that is dependent on the number of attacks that a plant has. So it knows how to create the volatiles and also what natural enemies of the predators for the insects to try and make its mix of GLVs to get the plant, the insect predator to come over and help the plant. And I can't remember if I said anything about the biodiversity, how important it is that we have this whole mix of plants and animals and the insects and their predators so that they all are able to function together as they've been inclined to do. Another interesting thing is some of those volatiles affect some insects or predators and not others. So like for the chili plant, a bird is a dispersal for the chili plant, so it can eat those chilies and the seeds don't have any heat in it for them because the seeds pass right through the birds, whereas mammals such as us, when we eat the chilies, they are hot. Okay. Oh, and I thought this was really interesting. So the plants will create that volatile based off of something that is happening, just like last week with the little bees when they land, and the nectar is released when the bee response is there. So trees are not just standing here. They are very responsive to all kinds of things that are going on. All right, so then the cost, this is another thing that they are responsive to, is the carbon emissions changes in the planet. And so one of the impacts that happens to trees is that when the CO2 plants, when the CO2 level increases, it changes the plant metabolism, and the CO2 is also warming our planet, and that affects the metabolism of the plants as well as the insects. And one example of that is with soybeans. So an increased CO2 level, the leaves in the soybeans have an increased amount of carbohydrates, so the percentage of defenses in the leaves is down, and that makes them very palatable to the Japanese beetles. So there's a lot of interplay that's going on, and it makes it really difficult to do prediction models of what might happen with all of this climate change that's going on. Our word for the insects is a type of photooxidant that is used as a defense against insects and possibly against fungus. It is phyrocumarins. Phyrocumarins, and I am picking it because it has 15 letters, and I very rarely get to use 15-letter words. Phyrocumarins. Phyrocumarins. All right, so for Ecological Economics today, we looked at operational sustainability, or operationalizing, I don't know how to say it, operationalize sustainability. So instead of just looking at the ecosystem services as flows, which is the exchange of services, this week we looked at looking at the ecosystem as a stock. So we looked at it as natural capital, and that would be thinking about inclusive wealth and expected wealth. You might could think about spending some money to go to grad school, and what do you expect to get out of that debt that you are putting yourself into? So we looked at the forest in this way. Ponderosa pines have gotten too thick, the forests have gotten too thick, so if we invest money in thinning the area, then we are creating better resilience of our forest, and that resilience then offers protection for the continued ecosystem services that the Forest Office offers, because if the fires come through in a very thick forest, then it's extremely destructive, but if we thin it and fires were to come through, there's less disruption of the services that the forest might be able to offer. So then we also looked at strong sustainability and weak sustainability. Strong sustainability is the understanding that natural capital cannot be replaced by human creations. We might be able to create oxygen, but nobody wants to walk around all the time with an oxygen tank, right? So then weak sustainability is what I feel like we're doing most of the time, which is we're just replacing one thing with another one. Say, for example, we're replacing the reliance on fossil fuels with just solar energy, which is at least a sustainability measure, but what we really ought to be doing is addressing our energy usage rather than just swapping one for the other, because solar energy may be cleaner, but it also comes at a cost to the environment. The word for ecological economics is wealth. It is defined as abundance of valuable possessions or money. And I think we should think about the little phrase that if you have your wealth, if you have your health, you have great wealth, and how that is applicable to our natural environment on which we depend. Okay, so for independent study, I've defined my project, and it is on environmental degradation, and I'm going to get to do a questionnaire to find out other people's opinions about this subject, and I'm going to explore the causal view of the causal line of thought on environmental degradation. And the particular topic that I am studying is people keep leaving their used toilet paper underneath rocks. And I found that really offensive when I was a wilderness ranger last summer. So I'm going to address this in my topic. I'm most likely going to have to research litter and just general pollution because unfortunately there's not a lot of research that has been done on this topic, even though there's a lot of evidence of it out everywhere when you go camping and backcountry hiking. So that'll be one gap I'm going to be able to fill in. And then it also needs to be very much solution based. So what? So I found this information, and then what? What will I be able to do with that? I need to submit my questionnaire to the NAU IRB, which is the Institutional Review Board. Well, I have to do that because I'm going to be talking to humans, and I want to make sure, the review board wants to make sure that I am talking to my human subjects correctly without offending them. And in the meantime, I can tell you that the best thing to do is be prepared. Take your Ziploc baggies with you and take all of that used toilet paper out. A word for the independent study is litter, which the Wikipedia definition is, consists of waste products that have been discarded incorrectly without consent at unsuitable locations. So again, pack it in, pack it out. The poem is from Yaso Busan, and it is, "Only Mount Fuji is left unburied by young trees." And that is in honor of spring equinox. I hope you will enjoy your week and get outside and consider how wealthy we are to have healthy lands to participate in. Ciao.